Alright, so this is the BJT NPN transistor, and there's two different kinds. There's a PNP and an NPN. They kind of work in reverse, so to speak, but we're just going to work off the NPN one, so don't worry too much about that because it's used for amplifying signals, and usually under about an amp of power you're using BJT transistors, and above an amp you're probably using MOSFETs. So here's what they look like, and I'll show you one physically later on. You can see we've got 1, 2, 3 for pins. Now, don't be fooled because pin 1 here, see it's got flat side and a curved side. Pin 1 here is not always a collector, and pin 2 is not always the base, and pin 3 the emitter, so you have to test or look up your transistors just to make sure so you don't have an issue. You can use a components tester, that's what I use. I'll show you that later on. And this is its symbol. Usually it has an arrow going down to the emitter to show that it is a NPN, right? So anyway, how do they actually work? Okay, so here is a tap, and transistor is functionally the same thing as a tap. You see we have an inlet, number 1, we have a valve, number 2, and we have an outlet, number 3. So water goes in and it is blocked or allowed by number 2, the valve here. The valve is the base. The collector is the receiver of water, and the emitter, you can think, emits water. So collector collects water, emitter emits water. So really electricity is going from, usually you hook your positive to the collector and the negative to the emitter, at least in these kind of basic amplifying circuits, and your base is hooked up to your signal that you're trying to amplify. And so it's like a switch. The tap is a water switch. When we turn the valve, it allows water to flow. When we stop it, it stops it. When we turn it a little bit, it allows a little bit of water to flow. The transistor is the exact same thing. And you might think, well, we could just use a switch. Wouldn't that functionally be the same thing? Because essentially what I'm saying is it's just a voltage controlled switch. You know, when you apply a voltage or a pressure, in this case, to the valve, it opens it up. And that'd be correct, but what we can do is that we can switch on and off the transistor lots of times in a second, which, 1 time per second is 1 hertz. 10 times in a second is 10 hertz. 100 is 100 hertz. Do you see where I'm going with this? So what happens is that the amplification of the signal is done through the base. Switching the signal is essentially just how often are you switching it on and off. It's an amplifier for hertz, for turning things on and off, right? And different waveforms, and I think different waveforms, I'm not sure, but I would assume that, right? And then whatever voltage you apply to, or in this case, how much water you apply to the inlet is how much you will get out, right? You'd assume. Assuming you would open this up fully, right? So that's why you can amplify the signal, is because you can apply extra water here. Okay, so here is the actual transistor. As you see, it's a bit hard to see, I'm sorry about that. It's got a flat side, and it also has a curved side. And usually I kind of like twist the wires like this so they're out of the way. I'm going to use my components tester to show you that they're not always the same, I guess. Okay, unfortunately my components tester was saying that the other resistor was, the other transistor was a resistor. Technically they are variable resistors, but I had to fix that up. I had to get another one, as you can see. So we have the flat face forward, there we go, and it says number 3, it's hard to see, there we go. Number 3 is the collector, number 2 is the base, and number 1 is the emitter. So in this one is back to front from the default pictures, which is a good thing while we tested it. So I'm going to make some circuits and show you how this works. Okay, so this might look a little bit confusing, but we have it on about 2 volts, and here is a transistor. So assumably this is the collector, emitter, and base, and you can see I found that you can put the the load, which in this case the light, kind of below, so attached to the emitter, and sometimes it works attached to the collector. So, you know, what is the right one? People seem to put it here, but whatever. And also I have this, it's like about a 3-volt battery pack, because 2 volts didn't work. I've got it grounded, so you can see the ground is just connected to the ground. Don't mind the weird wiring. And the positive is connected to the base. And if I disconnect it from the base, it, well, still, you know, sometimes you can actually touch it. I found, I don't know if it's certain transistors, but this one's kind of lighting up a little bit when I touch it. Yeah, some of them you can touch, and see, I'm touching the positive, so that's like electricity flowing through me, and you can like wirelessly, yeah, like this one kind of lights up a tiny bit, so I guess you can make touch activated stuff. I don't know, but anyway, pretty much when I touch it, so imagine you do that a bunch of times and we get a flashing light, right? Okay, so here's something kind of cool. So now I have the signal generator set to 1 hertz, and it's just powered by this battery here, and the negative is just connected to the ground of the whole circuit. But the positive here, if I connect it to the base, it starts, so it's going on, off, on, on, off, on, off, on, off, on, off. And you can understand things like duty, for example, duty percentage. If we turn that down to like 20, you can see it flashes a tiny bit, so it's 20% of the cycle. While if I turn it up to like 80, it flashes for 80% of the cycle, see? So then we turn it back to 50, so it's a half cycle. And then we turn it to 2 hertz, so it's flashing 1, 2, 1, 2, 1, 2, 2 times per second. 3, flash, 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 4. And you can see how eventually this starts to become, you know, really cool. And eventually, if we turn it up, oops, I turned it really high. If you make it kind of really high, you can't even see the flashing anymore. You see now on the, I can still see it, but on the camera you can't. Okay, now I can't really. So around like, oh, and you can still see it actually in the foreground of the camera. But I'll turn it to about 50, which some countries' electricity is that, and you can't really see it. You can, if you look at it, it almost looks like it's I don't know, vibrating or something. But yeah, so that's what we can do with a light. So here's an interesting one: is a motor. Look at that, 1, 2, 3. It's on 1 hertz. Okay, I'm going to turn it up to 2, and now 1, 2, 1, 2. See, it's pulse, 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 pulse. 3. Which is really cool. So if you wanted a motor to be pulsing, okay, so here's where things get really cool. Here's my speaker that I've got it attached to a jar. I'll show you why in a minute. Do excuse the jar's a little nasty, but you can hear that pop, 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 because we've got it 1, 2, 3, 4, 4. And we keep turning it up, and what happens is that hear that? That sound. And we can turn it up to higher frequencies. Now actually, the reason I have it like this is that, notice how it changes the sound? It sounds awesome. It's kind of hard, it might be a little hard to imagine because it's only playing a single tone, but yeah, no, it actually sounds really cool when you like play a song through it. I wish I could show you, but I don't have 2 phones to
use. But anyway,
Actually, so I used my webcam to take a quick video, but I think it's copyrighted music, so I probably shouldn't play it here. But if you check my Gab or Twitter down below and just check my recent posts, you'll be able to listen if you want to hear what the jar sounds like.
yeah, these things boost signals for like radios, microphones. I'm still trying to figure out how to get like other things like microphones working on it, but at least for the signal generator I can do this. So that's kind of what's so cool about these transistors.
All right, so for anyone who likes to look at this on like a board on symbols and all that for the circuit, so here we have our power supply, right? And one thing to always think about in like circuits, eventually when they get more complicated, at least I find, is that you think like the whole bottom row is just like things leading to the ground. So this is just things, I don't mean like the floor, but like the negative. This is all leading back to the negative, usually in parallel. If you look at like complicated circuits, you'll know exactly what I mean. And then like the top, it's like a top bus or a top bar. It's like if you have like a USB extender or like a power bar, like where you can plug in all your power leads. This is like that's kind of how these work. So anyway, so from our power, we go to, now either, as I said, people traditionally have the signal or like the microphone or whatever here, and I haven't been doing that. I don't know if that's a bad thing or what, but just you can do it. Otherwise, we'll just draw our transistor here. That, and then we go an arrow, so it's an NPN, and this is our base here. This is our collector, and this is our emitter, right? And as I said, it's just like a tube, and then you've got like the valve, right? And that's kind of pushing down this. So you want, it's trying to go from here to here, and if you open the valve, it opens it. Anyway, and then we have our, we'll just say like, I don't know, a light or something, right? I think lights are like, they're like a diode, but then they got some other symbol, I don't remember. So it's going back to the negative, okay? And then of course the base, if you connect it to either positive, again, to get some voltage, or some other alternate like power source here. So we got, and you ground that, I don't know, somewhere else, right? Or you just ground it on, hang on. Technically you just ground it on there, that'd be fine, right? So that's kind of how this works. And of course, really what you want to be doing is connecting this to a signal. I think that's a symbol for signal. So you like 1 hertz or like 2, 10, maybe 10 hertz. And that's getting powered from maybe this, and maybe if it needs to be grounded, right? So what I'm trying to illustrate beyond just the transistor is that I'm just plugging stuff into, wherever, like this whole area, again, it's like a power bus, right? And I'm just plugging things into like wherever on the bottom here. So if you really want to understand transistor circuits, you're going to have to understand that about how to read these things, right? But anyway, or if it's like a microphone, I don't know how to draw microphones, but we'll just have like a symbol like that. Usually your microphone, it'll be from here, right? Now this actually, I can't get this to work yet. I think because I might need a preamp for the mic, so we'll just do an M. But functionally, it should be fine. And usually you would also have a speaker around here, so we'd rub that out, and we'd have, though I think it, as I said, I think it can work there. I don't think it's, traditionally correct, or that it's like, I think people will get mad at you, but it works. Like, I've tried it out. It seems to work fine. I guess there's a debate of like, are things going from positive to negative or negative to positive or whatever. Anyway, whatever. So this is kind of like the basic speaker circuit, speaker transistor circuit. Again, this I can't get it to work yet, and also you would technically have a resistor there because you don't want to blow up your microphone, right? And then there's a bunch of capacitors and all this other stuff, which I don't really fully understand why they use them, but they use them. So anyway, right, so that's pretty much how it works. It's just your power going into both the speaker and a microphone, and the microphone signal being amplified by the transistor and affecting the speaker, right? So it makes power. And how you want to make that circuit is up to you. You know, if you want to make it like, as I said, there's lots of different ways to orientate these and all that, and you're just gonna have to figure it out what works and what doesn't. But I don't know, maybe that helps you a little more. I hope. I don't know. So really the best way to do this is to practice and try it out yourself. Transistors cost you a couple bucks for a pack of them. They're very cheap. You can get all the other components pretty easily. Just try it out, you know. Make sure to look up the transistor on a data sheet or to check it on component tester to make sure you know what you're doing. So you can, so you're not plugging things into the wrong way, I guess. Well, you'll figure that out. I showed this in one of the last videos, this tutorials point basic amplifier thing. You probably understand it a bit more here. You can see a transistor. So the input signal is going to the base, and this is an NPN. You see the downward, and it's got all these resistors here, and the output here, so I guess technically the load is, in this case, it's here. I don't fully understand all the transistors because, the resistors, because the resistors, in my understanding, of course, it's almost like a way to force amperage. It's like heats up the circuit and force amperage. I try not to use them unless you use really heavy, like really high percentage resistors. It seems like it's a practice in electrical engineering. They just put resistors everywhere, but then you get like a lot of power wastage, and I don't know. I think it's just one of those like, maybe I'm too silly to understand it, but maybe it's like people trying to over-engineer everything. But also, in audio, there's like filter and all this stuff. So, here's a more complicated one. When you start adding like capacitors. Now, if you're interested in amplifiers, look up amplifiers. I think it's A type amplifiers, B type, A B type, D type, and there's some other types. There's all these like types of amplifiers which are different. Like this is an A type amplifier. If you're interested in that, just anyway. But you can also see here the ground. So everything's plugging into the ground. When you start seeing resistors, it's like, oh yeah, they're plugging it into the ground. That seems to be just how, I don't know, like university educated engineers seem to work or something. And then here we see VCC. So it's like the sky and the ground, right?
Here's something that may be interesting. Here I have blown this one. As you can see, it looks like there's a copper sheet or something, and the other piece of plastic is just blown off because I put too many volts through it. So these little ones, they're great, but if you're trying to make like audio, like full legit, like high wattage audio, yeah, not so great.